Good morning. This is Dr. K. Adlin Suji, Assistant Professor, BCA Department, Bishop Weber College, Trichy. Now I am going to present a topic on fundamentals and data structures and algorithms, and the topic that we are going to see is doubly linked list. Now let us see the introduction to doubly linked list. Doubly linked list, it is a linked data structure that consists of a set of sequentially linked records called nodes. And each node contains two fields called links that refers to the previous and the next node in the sequence of nodes. When you see the diagram, you will be clear how a doubly linked list looks like. Start and end nodes, previous and next links respectively points to some kind of terminator, what you call it a sentinel node or null, to facilitate traversal of the list. If there is only one sentinel node, then the list is circularly linked via the sentinel node. This is the structure of the doubly linked list. Doubly linked list, as I said, it is a sequence of nodes which contains three parts. Each node contains three parts: the data part, previous pointer, and the next pointer. The next pointer points to the next node in the sequence, and the previous pointer points to the previous node in the sequence. The previous pointer of the first node and the last pointer of the last node will be equal to null. Traversal of the list is possible in either direction. Adding or removing a node in a doubly linked list requires changing more links. The operations are simpler and potentially more efficient, and there is no need to keep track of the previous node during traversal. Now let us see the taxonomy and implementation. The first node and the last nodes of the doubly linked list are immediately accessible, and the link fields of a doubly linked list node are often called next and previous or forward and backward, and the references stored in the link fields are usually implemented as pointers. Now let us see a small example of doubly linked list. First, let us see the motivation behind doubly linked list before going to the example. Doubly linked lists are useful for playing video and sound files with rewind and instant replay. They are also useful for other linked data which require rewind and fast forward of the data. First, let us see how will you delete a node in doubly linked list. Consider this example. In this example, we have 5 nodes. Suppose if you want to delete a node with the value 40. The node we are going to delete is called the current node. Before deleting, you need to do some steps before deleting a node in doubly linked list. Okay, see here, if you see here, the current dot previous dot next equal to current dot next, and current dot next dot previous equal to current dot previous. Once these two steps are executed, you need to destroy the node current using destroy node. See here, the brown color arrow shows the change of pointer. Okay, once you change the pointer accordingly, the node current will be removed. Next, we are going to see how will you insert a new node. If you want to insert a node called new before current node, you are not going to insert at front or rear. Okay, the steps that takes place before inserting is new dot next equal to current, new dot previous equal to current dot previous, current dot previous equal to new, and new dot previous dot next is equal to new. See here, the yellow line shows the pointers. See here, the pointers are shown accordingly. Once you inserted, the pointers will be changed accordingly. Next, let us see the simplified method to implement operations in doubly linked list. Doubly linked list with sentinel or head node. To simplify insertion and deletion by avoiding special cases of deletion and insertion at front and rear, a dummy head node is added at the head of the list, and the last node also points to the dummy head node as its successor. See here, this is the doubly linked list with dummy head. Okay, this is the dummy head node. Here you have 3 pointers. Okay, previous, next, and the head node. This is the empty list. Okay, the previous pointer of the first node will point to the dummy head node. Similarly, dummy head node's next pointer also points to the first node. See here the yellow line. Similarly, the last node's next pointer points to the head part of the dummy head node, and the next pointer of the dummy head node points to the last node. The brown color line shows the pointer, how first node, that is friend node, and the last node points to the dummy head node. This is the example, or this is the procedure. How will you create a head node? Okay, the procedure is void create head, which takes an argument node pointer head. Okay, head which is of type node ptr. Head equal to new node. You are creating a new node, and the head node next points to the head, and similarly head dot previous points to the head. Once you create a dummy head, then you can insert or delete a node at front or rear or in any position easily. Okay, thank you. Hope you have understood.